Stars that venture too close to a black hole face an enormous challenge. The gravitational force of the black hole is so strong that it can stretch and distort the star, causing it to heat up and potentially even tear it apart. This process is known as spaghettification, and it's a pretty gruesome way for a star to meet its end. The strength of the gravitational force depends on the mass of the black hole and the distance of the star from the event horizon. As the star approaches the black hole, the gravitational force becomes stronger, causing the star to move faster and faster. The star's orbital path becomes more elliptical, bringing it closer to the black hole with each passing orbit. The intense gravitational force also causes the star to heat up, potentially leading to the emission of intense radiation. This radiation can be detected by telescopes, providing scientists with valuable insights into the interactions between stars and black holes. The risks of being torn apart by extreme gravitational forces are very real for stars that venture too close to a black hole. In fact, scientists have observed many stars that have been destroyed by black holes, leaving behind a trail of gas and dust that can be seen for millions of years. The destruction of a star by a black hole is a catastrophic event that releases an enormous amount of energy, which can be seen from millions of light years away. When a star approaches a black hole, several scenarios can occur. The star may be torn apart by the strong gravitational force, or it may be consumed by the black hole, adding to its mass and spin. In some cases, the star may even survive the encounter, emerging on the other side with a new orbital path. The interaction between the star and the black hole is complex and depends on many factors, including the mass of the black hole, the distance of the star, and the velocity of the star. Tidal forces play a crucial role in the interaction between a star and a black hole. These forces cause the star to stretch and distort, leading to the emission of intense radiation. The strength of the tidal forces depends on the mass of the black hole and the distance of the star from the event horizon. Accretion disks, which form around black holes, also play a crucial role in the interaction between stars and black holes. These disks are made up of hot, dense gas that spirals into the black hole, emitting intense radiation. The formation of accretion disks around black holes is a complex process that involves the interaction of gas and dust with the strong gravitational force of the black hole. The disk is made up of hot, dense gas that spirals into the black hole, emitting intense radiation as it heats up. In some cases, the accretion disk can even lead to the formation of new stars, as the gas and dust in the disk collapse under their own gravity. This process is known as star formation, and it's a crucial aspect of the evolution of galaxies. Recent discoveries have shown that some stars can indeed survive their close encounters with black holes. These stars, known as hypervelocity stars, are ejected from the galaxy at incredibly high speeds, often exceeding millions of kilometers per hour. The ejection of these stars is thought to occur when they interact with a supermassive black hole at the center of the galaxy. The discovery of hypervelocity stars has provided scientists with valuable insights into the interactions between stars and black holes. The discovery of stars that survive their encounters with black holes has also provided scientists with valuable insights into the properties of black holes. By studying the motion of these stars, scientists can infer the mass and spin of the black hole, as well as its impact on the surrounding galaxy. The study of these stars has also led to a greater understanding of the evolution of galaxies, including the role of black holes in shaping their structure and evolution. In another fascinating case, scientists have discovered a star that is actually orbiting a black hole. This star, known as a binary black hole system, is thought to have formed when two stars merged to form a single massive star that eventually collapsed into a black hole. The orbiting star is thought to be slowly spiraling into the black hole, eventually leading to a catastrophic collision that will release an enormous amount of energy. The study of stars that interact with black holes has also led to a greater understanding of the role of black holes in the evolution of galaxies. Supermassive black holes, which reside at the centers of galaxies, are thought to play a crucial role in regulating the growth of galaxies, including the formation of new stars. The study of these black holes has also led to a greater understanding of the properties of dark matter, which is thought to make up approximately 27% of the universe's mass-energy density. The relationship between stars and black holes is complex and fascinating, with many factors determining the outcome of their interactions. Thanks for watching. Don't forget to leave your thoughts in the comments, and be sure to check out my other videos on space phenomena for more exciting content.